Hello dear students, so I welcome you to the next lecture of novel drug delivery systems, and as of now we have discussed the basics of microencapsulations and why we are using microencapsulation technique, what are the rationals, the advantages and disadvantages, and from the previous lecture we have started the various processes which are used, or I should say the technologies used to prepare a microcapsule. So in today's session I shall be discussing with you or giving you a brief overview of the various processes such as in situ polymerization. So you must be connecting with means in the previous lecture we have discussed the interfacial polymerization. So another process is there which is known as in situ polymerization. In this technique we shall be discussing how a polymerization process is governing, means on the very site where we are adding the polymers and they are forming the polymeric coat on the system. Coming towards the second objective of our today's session is the electrostatic process. So as the name says, in this electrostatic we are using the means interaction, or we are just trying to interact two oppositely charged moieties, and both the polymer as well as the drug moiety will be in the fluidized state, or I should rather say in the aerosol state. So this is the electrostatic. Coming towards the next is the precipitation technique. So as the name says, we are trying to separate out the polymeric system or the drug coated polymeric system, means with the process of precipitation or salting out process. And last but not the least, we are trying to sum up this session with the hot melt technique as well. So these are four objectives for today's discussion. So as the polymerization technique is there and we are using the in situ process, so in this technique the direct polymerization of single monomer is carried out on the particle surface. So this is the very important aspect related with the in situ polymerization. And very important aspect related to in situ polymerization is no reactive agent is actually added to the core material. So this is the uniqueness of this particular in situ polymerization, and this also differentiate it with the interfacial polymerization, because we are not adding any reactive agents to the core. So our core is protected and no chance of interaction should be there using this in situ polymerization technique. And the process governing of this in situ polymerization is depicted over here. You can see initially a low molecular weight pre-polymer will be formed, and as the time will slowly pass and gradually the polymeric coat will grow in size. It will develop layer by layer onto the core, followed by deposition on the surface of core material, and this will actually generate a solid capsule shell. So this is the process governing in situ polymerization. So you can see I have taken this wonderful pictorial representation from the source microcapsule technologies. So you can access this link for further clarification and the detailed description of in situ polymerization. So I have just summarized the whole process over here. So what we are trying to do, we are dispersing the liquid which is to be encapsulated in the aqueous medium, and you can see the size of the droplet is controlled with the regular agitation by the stirrer over here. Now you can see we are adding the two types of monomers, monomer A and monomer B. Obviously they will be in solution form. So now they will be added into the system, and you can see in the next step the initiation process will begin, and the polymer which we have added will try to develop a polymerization coat on the core material. Similarly, the last step will be of stabilization of polymer structure. So this is the nutshell of in situ polymerization. Coming towards the next topic is of or the next technology is the electrostatic method. So as the name says, we are using or we are just trying to interact two different charged particles. So the electrostatic method is useful when the coating material and drug which is to be encapsulated are both in the aerosol and should be oppositely charged. So this is the uniqueness of this system. So how this system works actually? The drug means the core and the coating material are atomized, resulting in the formation of the microcapsules, and when they are means the temperature is reduced, they are collected and the aerosol microcapsules are basically produced. Coming towards the next point of discussion or the next technology is the precipitation process. So in this precipitation, the actual objective behind this technology is to precipitate or congeal a preformed polymer around the drug being encapsulated. So the example, I have taken some examples. So you can see the precipitation of ethyl cellulose from cyclohexane, which is obviously the solvent, and the process is governed by the effect of temperature. Another example, you can see gelation of sodium alginate with calcium salts which are positively charged obviously. So this is also a precipitation process. Coming towards the another point of discussion or example which I have portrayed over here is the desolvation of water soluble polymer when we are mixing with the miscible solvents. So nowadays this technique is very much interesting or very much in means limelight, we can say, the salting out method. So you can see I have taken this beautiful pictorial representation from a wonderful article published by Lee et al. So you can access this article on the website and you can have the detailed discussion of salting out method, and various other microencapsulation processes are also given in this article. So the salting out method involves addition of salt to an aqueous polymer solution, and which actually separate the polymer from the solution. So you can see we have taken aqueous solution which has the composition of distilled water, PVA, that is polyvinyl alcohol, or some stabilizer can be used similarly, and the salting out agent is either MgCl2 or calcium chloride. So you can see into this aqueous solution we are trying to add drop by drop through a hypodermic needle the organic solution, which is consisting of the organic solvent, the drug, and the polymeric system. So these are added drop by drop into this regularly agitated system, and you can see the system is developed in this particular fashion, and after a sufficient time you will be getting the micro particles with controlled size. Only concern with this salting out method is, as we are trying to add a salt or the salting out agent like MgCl2 or calcium chloride, so this will add an extra concern for toxicity or certain means if the appropriate amount is not added, so it will actually increase the concentration of salt in the capsule wall. So you have to be very much cautious while choosing the salting out method. Coming towards the next technique is the hot melt technique. So as the name says, we are trying to use the temperature, elevated temperature, to melt the polymeric system, and in that melt the drug will be encapsulated. So hot melt technique involve mechanical drop formation at an elevated temperature, and this is then subsequently followed by a cooling step. So the temperature will be subsequently or gradually reduced. Now the hot melt coatings are composed of relatively low molecular weight lipids, and these coatings have low melt viscosity, so they have high fluidity, and they also offer reasonable operating temperatures, and they can also be sprayed using some spraying machines. So the only concern with this hot melt technology, or we can say disadvantage with this hot melt technology, is that only those drugs which are means which are not thermosensitive can be incorporated or can be encapsulated using this approach. Otherwise, if the drug is thermosensitive, so this technology fails in that particular case. So thank you, dear students. In the upcoming lectures, we will be discussing remaining technologies for microencapsulation, that is air suspension and solvent evaporation.